Hi, this is Nachi. Welcome to this video on unit testing. This video is going to be a short and a conceptual one. So the target audience could be developers or managers. What is unit testing? We can consider an application to be made of units, and testing these units is unit testing. That actually seems to be a very simplistic definition, but I guess this definition is enough for now. Even this simplistic definition has given a big question to us. What is a unit in unit testing? Is it a class? Is it a method? Or is it a feature? Unfortunately, the industry has not defined this well for us. So we could define it. We could define it in a way to make the best out of unit testing. So to define it, we need to understand what we want to make out of unit testing. Unit tests should test requirements. Suppose we have these, and a requirement is to connect them. And now when we unit test this, the test should fail because it's not connected. On the other hand, if we connect it this way, the unit test should pass because it's connected. Unit tests should act as regression tests for old requirements. Suppose we get a requirement to connect the purple lines and we connect it this way. The unit test for that should pass, indicating it's connected, whereas the old unit test should fail, indicating we have broken an old requirement. This benefit provided by unit tests is one of the biggest benefits. And I think the industry is trying to popularize unit tests mainly because of this benefit. So when we are implementing a new requirement, often we take an old requirement. And if it is older times, a poor tester has to go through all these things and test it. And now when we have unit test, we have the freedom to modify code as we want, and we trust the unit test will take care of our old requirements. Unit tests should be independent of implementation details. Now let's go back to the first scenario. For this, if you wrote a unit test like this, that is, if a straight is available, and then if a right is available, and then if a left is available, and so on till we go out and declare the test as pass. This test is very close to the implementation details. When the implementation details change, the test is going to fail. And this is a false negative failure. We don't want this. If this happens, the test stop being as a regression test. When the unit tests stop being a regression test, the biggest benefit of unit test is lost. Let's see what happens in the development environment in this scenario. The developer realizes some of his tests are failing, some of his old unit tests are failing. And he realizes they are failing because of a change in implementation detail. So he modifies the unit test to match it to the new implementation details. He would often do this without checking the requirements. And when he does this, he could introduce an error in the system. So the biggest benefit of unit tests acting as a safety net is lost here. Moving on next, we want the unit test to be easily readable. Sometimes there is an attitude amongst developers that this is just unit test code. They might pay a lot of attention to make a production code readable, but they might not do the same for unit test. What we got to understand here is we're making production code readable not because it performs better, because it's easy to read so that we can modify it easily. So if that's the case, unit test code also needs to be modified, so it has to be easy to read. So maybe we should put more attention to make it more readable. Another aspect is unit test should clearly be readable and mappable to a requirement. Unit test is nothing but testing a requirement. So we should clearly know which requirement is getting tested by this particular unit test. So there should be no cryptic mapping between requirements and unit tests. There should be a direct, straightforward one-to-one mapping. Unit test code must be easy to write and modify. It's actually not only for unit test code, even production code should be easy to write and modify. The advantage for production code is there are tons of libraries available outside, which makes it easy for you to write the production code. So anything that's not business logic, you could actually find a library or something which helps you do this. This is not true for unit test code. The unit test infrastructure or the ecosystem is not so well evolved. So a lot of times what happens is we end up writing these infrastructure code which bloats our unit test code. And when not clearly segregated from the test code, this makes the code less readable and gives a feeling that it's difficult to manage. Execution of unit tests should not have any side effects. Let's look at this with an example. Imagine we're building an online food ordering system. In the system, you can place an order for food, and after ordering the food, you can make a payment by the payment gateway. In the enthusiasm of unit testing, we should not completely unit test this code. In this application, there is a thin layer of ORM which puts in records into the database and gets out records from the database. If we unit test this layer, we could accidentally put in records into the database. There is also a thin layer of payment interface, and you definitely don't want to unit test this. As a side effect of execution of unit tests, you don't want to see some credit card getting charged. We have come to end of this section. We have set up our expectations from unit test. Now let's look at our application. Let's look what are the things in the application that could be a unit candidate. Then once we have this, we will compare which is the best. We can consider this box to be an application. An application could be seen as being made of multiple features. A feature is a bunch of code that gets one requirement completely done. And they might not really have a physical boundary inside your code. There could be multiple classes interacting with each other to get a requirement realized. This is one way of looking at the application. Another way of looking at an application is as layers. There could be many layers such as controllers, models, views, etc. These are more into the architectural segregation and based on what they are doing. Yet another way of looking at application is as a bunch of classes. And these classes may be used by a single feature, or maybe by two, or maybe even by all the features. Now that we've seen various views of application, let's see what are the possible unit candidates. It could be a class, it could be a layer, it could be a feature, it could be a feature minus some classes, it could be a bunch of classes. Now we have 5 candidates that could be units. Maybe let's just take a closer look. Class. Many people actually use class as a unit in unit testing, so that's okay. Layer. Generally not a good unit, and I don't think many people are using it, so we really need not worry about that. Feature. It might not be possible to use feature as a unit because feature will generally contain some classes that should not be unit tested. Like in the previous case we spoke about ORM layer or a payment interface layer. Feature minus some classes. Okay, this actually is ideal feature because we've removed the classes like payment interface or ORM. So this actually works. The last one, a bunch of classes. This also works. We've come to the last section of our video, evaluating the unit candidates. We have 3 shortlisted candidates now. Class, feature minus some class, and a bunch of class. We can actually narrow down this to 2. Class at one end and feature minus class at the other end. A bunch of classes somewhere in the middle. So it's a trade-off. So if we evaluate class and a feature minus some class, we have the data. Hi, I hope you enjoyed the video till now. So the conclusion is yet to be produced. So your feedbacks at this point could be helpful. Thank you.